Hello everyone. Now in this video I will just quickly demonstrate or show how to select deterministic terms in Johansen cointegration test. Sorry. And this seems to be an interesting issue, or maybe a difficult one, especially for those who are just doing applied research or are doing master's research, I should say, in economics. What I mean is this. So let's assume that we have some data here. Let's say it's multivariate cointegration analysis method. So we'll choose 3 variables here. If I have 2 variables, I would be using single equation model of angle triangle. Now I selected my variables. Let's call them just group. So let's open them as a group. Let's assume that you've done your unit with this. This is an assumption that's, well, let's assume it away, not to waste the time. So, and there are unit roots, and if you need help with the unit roots and how to do unit root tests, then there are videos on YouTube and in my channel as well. So let's then go to view. So these are 3 variables we have. Let's say GDP, capital stock, and labor. We go to view and go to cointegration test. If I had only 2 variables, I would use this, otherwise your Johansen system. And we would like to test now whether there is a cointegrating relationship, in other words, long run relationship between the 3 variables I've chosen. At most I can have 2 relationships here. I have 3 variables, so usually you have n-1 cointegrating relationship, assuming that n is number of variables, because it can only happen between the 2. Then you need at least 2 variables for a cointegrating relationship. Now, these are the ones that we're looking at today. If you assume that there is no deterministic trend in the data, in other words, if you assume that none of these variables have trends, like none of them move upwards persistently. In other words, if they move erratically and they do not trend up or down stochastically or persistently, or in other words, time determined fashion as well, then you have to choose this first option. This is less likely and may not be empirically observed for cointegrating relation between 2 variables, because this could even be a case of stationary process, each variable on their own. So it says no intercept or trend in cointegrating equations, so this is your long run equation, or in var. So this is when you are looking at the first differences in the var system. So in other words, if we let me open quickly this to say what it is, what the first means. So usually when you run an error correction model, sorry, this is too sensitive. This is the sort of model you get alpha. So this is your adjustment coefficients. You call this this is your matrix for long run equation or cointegrating equation, and your p-1. So first lag in levels, plus obviously you will be lagging using the lags from 1 to some maximum lag -1 of some of the y's. I mean, this is the data matrix altitude, so let's say this is sorry, and we'll have a channel of y's. Same j for some reason, plus then error terms t. Now this is your var system basically, in the sense that because this part here is basically part of the var. The whole thing is a var system, vector autocorrection, and alpha is just an error correction parameter for one of the stationary variables. This is basically, this combination is also changed in some Z, which is stationary. And these are also assumed to be stationary because you can't run a var in levels. I mean, you shouldn't run var in levels if the variable is unstationary. So alpha is basically a parameter in a var, and this beta times this will be a stationary variable, zt, for example, and this is if it's not stationary, you don't get nice alpha here anyway. So now the first one here, let's go back. This first case says no intercept and nor trend. In that case, this is the sort of model you will be running. So there is no intercept here in this whole equation, and no trend. Now that is the case in the data as well. So if you feel like the data does have a zero mean, then it's stationary processing. You should this basically this whole thing possibly collapse to zero because it's already stationary. Data is already stationary. Next is when do you choose this? It's when intercept in cointegration equation, but no intercept in var. In other words, if your data is stochastically trending, let me show you what it is in the equation here. Basically, in this case, you will have well, this thing here, this equation will be slightly different now. This will be now like t plus some let's call it c constant. This will be a quite Lohmann equation. In the cointegration equation, you will include a constant. So that is the second case, but no constant in the whole var system here. So that's the case, and this is when you have stochastic trending or non-zero mean variables. How about this? Third. Now in this case, intercept in cointegration, but still not a trend. Also in the var model. So basically in this case you will include trend in the whole var. So you just add another c here, c1 plus this whole thing plus this part. This won't replace, this replace. So the constant in both. So in other words, this assumes that the change in yt is actually non-zero. If it had a zero mean, then that will be the first case. So when to include this now? So by the way, when you include intercept in cointegration equation, you are assuming some sort of stochastic behavior or realization of random process. So let me show you what it looks like in terms of data. When you graph, it looks like this. It's basically moving up and down. Like stochastic. It's not deterministic like this. So it's stochastic. You can watch a video on YouTube as well on my channel. There is a talk about this. Okay, this one, fourth one. Intercept and trend in cointegration equation. No intercept in var. So basically, in this case, you should include an intercept in the var, but a trend and an intercept in cointegration equation. What does it look like? Well, this is only when you have this second case. So you add the t here, basically. You add some trend variable here. It's just trend variable that you can create from 1 to some final value. So this includes, let's add t here, t, yeah. But no t on this one. So if your data looks like something, not all of them are good, this is a train stationary process. In levels, not in change, or not in process. So some of the data looks like this, and yes, I'm talking in very simple language. So hopefully it's good to understand. Yeah, that's when you choose the fourth option in this list. Next one is number 5. In this case, the thing is, here you will include the trend t term in both in cointegration equation and in what it would be this. Oops. Sorry for that. Okay. In this case, you will basically stick a t here. Stick a t, which is a trend. Well, obviously, don't forget there is the coefficient for t as well. Coefficient for t where c is just so I'm missing it. So c plus t plus this thing, this whole thing, including the t, and the remaining negative terms. So this would possibly not be realistic. I mean, empirically, there is no data. Well, there possibly is when the first difference is 10. This is a possibility, but yes, you can have t restricted to the cointegration equation. So that's why we call it restricted trend. But unrestricted is when you have it in the whole system. Okay, so these are the cases. I hope gives you the basics. So this one is something that you can use if you really don't know what's to specifically. Just tells you which model is the best by looking at this. So if you take the well, we can choose any of the criteria and see which one of these have the highest log likelihood values in this case, and then follow this option. However, it is best to start with your own intuition and try to find yourself and then test this. And in many cases, I wouldn't rely on this case because it's more mechanical than intuitive, and data sometimes maybe choosing. I mean, it's basically this is data driven, not your something, not your own analysis. So data may say, okay, this is the one, I can fit it very well, but it's at the end of the day it may produce misleading results. So it's best to follow theory if you have anything in theory, or if you're testing on theory, or just follow intuition. Of course, you have the unit root tests and others. So yeah, this is a very short video. Hopefully, it will not be very boring, and we'll come back for the full kind of testing process later. But for now, for those who are looking for some clarification on this video will hopefully help you. And if you have any comments, leave them. I'll try and look and then record more videos on this. Okay, and thank you for watching. See you later.